Leibniz theorem is what? Basically, derivatives of antiderivative. So what it is? Derivatives of antiderivative. Derivatives of antiderivative. Is there anybody who is aware of this concept, who has already studied it? Vedant, Bhagat? Shivamani, have you studied earlier? All right, Bhagat said no. So I think most of you have not done it yet. See, the concept is, first of all, I'll give you in a simple language. Say you want to differentiate d by dx of integration, say phi x to psi x. There is a function ft dt. So how do we differentiate it? First of all, in the integrand, we put the upper limit. So that is f of psi x into derivative of upper limit psi dash x minus f of phi x into derivative of lower limit f phi dash x. So first of all, you place the upper limit into its derivative minus you place the lower limit into its derivative. Like for example, you want to do d by dx of x square to x cube sine t dt. So how do I do it? First of all, I'll place the upper limit, that is sine of x cube into derivative of x cube is 3x square minus sine of x square into derivative of x square is 2x. So upper limit into its derivative minus lower limit into its derivative. All right, one more example if I take, say 0 to sine x d by dx into tan inverse t into 1 plus t dt. So what you will do? First of all, you will place the upper limit, that is tan inverse of sine x into 1 plus sine x. Derivative of sine x is cos x minus derivative, since the derivative of lower limit is 0, the entire value goes 0. So answer is simply tan inverse of sine x into 1 plus sine x into cos x. Am I correct? Done. Now see, simply one or two questions if I do cover from the JEE only. See, there was a question once, limit x approaches to 0. Limit x approaches to 0, 1 upon x cube, integration 0 to x t ln 1 plus t upon 4 plus t to the power 4 dt. Say you want to differentiate, you want to find this limit. So we all are aware of L'Hospital formula, aren't we? So I write it like at limit x approaches to 0, integration 0 to x, t ln of 1 plus t upon 4 plus t to the power 4 divided by x cube. Now what do? You just differentiate the numerator as well as in the denominator using L'Hospital rule, because it is already a 0 upon 0 form. Got it? So derivative of numerator will be put the upper limit x ln of 1 plus x upon 4 plus x to the power 4. Now derivative of lower limit will be 3x square. Am I correct? So now 1x cancels 1x. So you get limit x approaches to 0. ln of 1 plus x upon 3 into x into 1 upon 4 plus x to the power 4. Now this ln 1 plus x upon x is 1. So answer will be 1 by 4 3 is 12. This is your answer. See, such a delicate question it is. Got it? Now, I'll write a question for you. That is also previous year JEE question. Integration sine x to 1 t square ft dt is equals to 1 minus sine x. For every x which belongs to 0 to pi by 2. Find f of 1 by root 3. Options are A option is 1 by 3, B option is 1 by root 3, C option is 3, and D option is root 3. Okay, solve it. Then I will launch a poll for your correct marking. Yes, there you go. Whatever the answer you got, mark in this poll. Okay, two people marked Calcutta, one marked Bombay. Others also contribute, please, quickly. Got D. Very good. All right, that's enough for this poll. Now let's see. Directly differentiate. So if you differentiate, upper limit will become, if I place the upper limit, then derivative of upper limit will be 0. So it is 0 minus lower limit, that is sine square x into f of sine x into derivative of sine x is cos x is 1 minus sine x, 1 derivative 0 minus sine x is minus of cos x. Am I correct? So your f of sine x became minus minus will become plus, cos will cancel, 1 upon sine square x. Correct? Simple it is. Now put sine x as 1 upon root 3. So f of 1 by root 3 will be, this is 1 upon 1 by root 3 whole square. That is 3. Very good, whoever answered Calcutta. Very good. Correct? Now, write down another question. Let f from 0 to infinite to r, capital Fx is integration 0 से x small fx dx. Small ft dt. Now, if capital F of x square is x square into 1 plus x, then find f of 4. Small f of 4 they are asking. Keep an eye over the capital in small f. Answers are can be A 5 by 4, B is 7, C is 4, D is 2. Yes. What should be the correct answer? Mark your answer in this poll. Okay, I got one answer. Well, see, they are providing you capital Fx as 0 to x small ft dt. Capital Fx as 0 to x small ft dt. Now, if you differentiate it, you get capital F dash x as small fx. Am I correct? Now, I differentiate the second equation. That is capital F dash x square into 2x is 2x plus 3x square. Am I correct? Now x is not 0, so you cancel x. So capital F dash x square will be what? Small f of x square is equals to 1 plus 3 by 2x, 1 plus 3 by 2x. Now see, domain is of f is always more than 0. All right. So in this equation, if I put x equals to 2, then small f of 4 will be 1 plus 3 by 2 into 4. So it is 2. So it is 1 plus 6. Answer is 7. This is your correct answer, Bombay. Correct? Am I clear? Take a look. Do it quick. All right, guys. Now one more question we will do, then we'll move forward with a new concept. For x more than 0, let small fx is integration 1 to x ln t upon 1 plus t dt. Got it? Find the value of f of e plus f of 1 by e. Yeah, please try it. Yeah, have you tried it? Why I have given this question? Because while this came across students, it is also previous year JEE question. So when this question came across students, what did they do? They started applying Leibniz theorem here. Getting my point? So they started applying Leibniz theorem, but Leibniz theorem does not work. It's not required here. It will work, but it's not required here. So whenever you see variable limit, that does not mean that you have to differentiate it. So how do I do it? Say if I go with f of 1 by x, it will be 1 to 1 by x ln t upon 1 plus t dt. Now let us use a substitution t equals to 1 by u. So dt is what? Minus 1 by u square du. So it will be lower limit will remain x, upper limit will be 1, upper limit will be x. So ln of 1 by u upon 1 plus 1 by u into minus 1 by u square du. Am I correct? So it will be from 1 to x. Now it is minus will become plus. It will be ln u upon u into 1 plus u du. Got it? Which can also be written as 1 to x ln t upon t into 1 plus t dt. Correct. Now, this was the given question to you from 1 to x. This is a condition that you have obtained for f of 1 by x. Add both of them. So, fx plus f of 1 by x is what? Limit same 1 to x. One function is ln t upon 1 plus t. Other is ln t upon t times 1 plus t dt. 1 to x. Take ln t upon 1 plus t common. It is 1 plus t upon t. 1 plus t cancel. So it is ln t square upon 2. Limit will be from 1 to x. So what it will become? Ln x whole square upon 2. Ln 1 will be 0 minus 0. Now put x equals to e. So f of e plus f of 1 by e will be ln e whole square by 2. The answer is 1 by 2. Very good question. No Leibniz, but question look like it's a Leibniz theorem question. Have a look. Yes, quick. Now, there is a Wallis theorem. As such, very few questions seen over it. But yes, for the sake of doing, you can do it. Remember the formula. The question says, this is a this is a special type of integral formula whose limits from 0 to pi by 2, and integration is either integral power of cos x or sin x cos x. So if you get 0 to pi by 2 sin x to the power n dx, using property 4, this is also 0 to pi by 2 cos x to the power n dx. Yes or no? And answer will be C, n minus 1, n minus 3, n minus 5 up to 5, 3, 1 divided by n minus 2, n minus 4, n minus 6 and so on up to 4, 2 into pi by 2. Got it? This is when n is some even number. Got it? And if n is some odd number, if n is some odd number, then it will be like n minus 1, n minus 3, n minus 5 up to 6, 2, 4, 2. Definitely it will go up to even number divided by n minus 2, n minus 4 up to this. This is it. So see, you don't have to remember n even and odd, whatever it is. So in numerator, we'll start with n minus 1, n minus 3, n minus 5 and so on. Denominator, we will start with n minus 2, n minus 4, n minus 6 and so on. Multiplied by pi by 2. And if it is odd, everything is same, but there won't be any pi by 2. Got it? Now, if it is sin x to the power m cos x to the power n dx. Now, again, same type, numerator will be m minus 1, m minus 3, up to 2 or 1, wherever it goes, depending upon m is even or m is odd. n minus 1, n minus 3, up to 2 or 1, upon m plus n minus 2, up to 2 or 1, multiplied by pi by 2. You will apply this when m and n both are even. Otherwise, it is simply m minus 1, m minus 3 up to 2 or 1, n minus 1, n minus 3 up to 2, 1 divided by this. M plus n minus 2, m plus n minus 4 up to 2 or 1. This is for any integer. Like a simple question if I take, so they are asking you I equals to integration 0 to pi by 2 sine to the power 4x cos to the power 8x dx. If I directly try to solve it, it is going to be really lengthy. So now here it will be what? Starting with m minus 1, you see it here? So it will be 4 minus 1, 4 minus 3. That's it. Then it will be 8 minus 1, 8 minus 3, 8 minus 5, 8 minus 7. Divided by 8 and 4, 12. So it will be 12 into 10 into 8 into 6 into 4 into 2 up to 2, and then you will multiply it by pi by 2 because m and n both are even. So your answer will be 1 into 3. Here it will be 7, 5, 3, 1 upon 12 into 10 into 8 into 6 into 4 into 2 into pi by 2. This is going to be your answer. If you can simplify it any further, much better. If you cannot, I cannot do anything. Got it? So this is what we call Wallis theorem. Now, definite integration as a limit of sum. Earlier, this topic was also there in the board also, in your CBSE board, but like because of COVID and reduction of syllabus, they rejected it. Okay, this topic has been eliminated from the syllabus. Now, what exactly do we do in these kind of questions? So, say you have a limit of sum. Limit of sum means you have a function which is in the form of f of r by n into 1 by n, sigma r from 1 to n, and limit of n approaches to infinite. All these things should be there definitely. Or you have a function 1 by n f of r by n r varying from 1 to n minus 1, limit n approaches to infinite. So in both the cases, what do? We replace r by n as x, 1 by n as dx. You replace sigma simple by integration. Now, according to r by n, decide lower and upper limits. According to r by n, decide lower and upper limits. Got it? Now, just as an example, if I take C. Without taking example, it's very difficult to understand. See, the question is find limit n approaches to infinite, sigma r varying from 1 to n upon n square plus nr plus r square. They're asking you to find this limit. All right. So how do I do it? This is limit n approaches to infinite, sigma r varying from 1 to n. Now see, do one thing. Take n square common from the denominator. So you get 1 plus r by n plus r by n whole square. Am I correct? So your 1 n cancel. So what you are left with? Limit n approaches to infinite, sigma r varying from 1 to n. So 1 upon 1 plus r by n plus r by n whole square into 1 by n. Now, what did I tell you? How to convert this? Sigma, you change it to integration. 1 by n replaced by dx and 1 upon 1 plus x square. Now see, you have done r by n as x. Now while r is 1, so x is what? 1 by n and n approaches to infinite. So limit will be 0. If r ki value is n by n it is 1, so x upper limit is 1. Got it? Now you need to solve this integration. So that is integration 0 to 1 dx upon x square plus x plus 1 by 4 plus 3 by 4. So that is 0 to 1 dx upon x plus 1 by 2 whole square plus root 3 by 2 whole square. So answer will be what? 1 by a. So it is 2 by root 3 tan inverse of x plus 1 by 2 upon root 3 by 2. Limit is from 0 to 1. So it is 2 by root 3 tan inverse of, if you put the upper limit, it will become tan inverse root 3 minus if I put the lower limit, it will be tan inverse 1 by root 3. So it is 2 by root 3 times pi by 3 minus pi by 6. So if you simplify it, you get pi upon 3 root 3. This is how we do the definite integration as a limit of sum. Got this? Have a look. This is a bit of critical, tough concept. Just have a look. Oh, I think you have got it. Now let's go. See, there are multiple. See, first of all, let's do this question. This concept we have studied just today. So I give you 2 minutes to answer it quickly. Yes, everybody quickly attempt it. Yes, only one has been able to answer. See, this is limit x approaches to 0. Now I'm applying the L'Hospital rule. So applying the upper limit, it will be sine of x, derivative of x square is 2x, and derivative of x cube is 3x square. Now 1x cancelled by this x, and one limit x approaches to 0, sine x pi x becomes 1. So answer is what? 2 by 3. Very easy, simple question. Came in JEE Mains 2021. Got it? Now see, apply, do this one. This is definite integration as a limit of sum. Quickly do. Yes, now you must have tried it. Mark your answer in the poll. Yes, try it quickly. All right, I got C answer from one candidate. C. Let me do it for you. Let us like reevaluate this question as limit x approaches to infinite. It should be n approaches to infinite. N approaches to infinite. I write it n upon n plus 0 whole square plus n upon n plus 1 whole square plus n upon n plus 2 whole square and so on n upon n plus n minus 1 whole square. Reread this question like this. So this is what limit n approaches to infinite. R varies from 0 to n minus 1. So it will be n upon n plus r whole square. Am I correct? So that would be limit n approaches to infinite sigma r from 0 to n minus 1 n upon n square 1 plus r by n whole square. Now we'll do everything the same. 1 by n as dx and r by n as x. So it will be integration 0 to 1 dx upon 1 plus x whole square, which is 1 plus x to the power minus 2. So it is 1 plus x to the power minus 1 upon minus 1, limit 0 to 1. So if you place 1, it will be minus 1 by 2. If you place 0, it will be 1. So answer is 1 by 2. Got it? C is your correct answer. Am I correct? Have a look. Now, all right. You just now we'll do some mixed kind of question. You start with this one. Pi by 6 to pi by 3 10 cube x sine square 3x. 2 secant square x sine square 3x plus 3 tan x sine 6x dx. Give it a try. Yes, quickly. All right, mark your answer in the poll if you found it. All right. All right. Now see, three students marked, all three marked different answers. Bombay 1, Calcutta 1, Delhi 1. See, the question is integration pi by 6 to pi by 3, tan cube x sine square 3x. It is 2 secant square x sine square 3x plus 3 sine 3 tan x into I write it 2 sine 3x cos 3x. If you see it very carefully, this pi by 6 to pi by 3, don't you see? It is the derivative of 10 to the power 4x, 10 to the power 4x into 3 tan x. Yes, 10 to the power 4x into sine to the power 4 3x whole divided by 2. Yes. But this is shear analysis. And analyzing this is not really easy. See, 10 to the power 4x derivative is 4 tan cube x into secant square x. So it will be 2 tan cube into sec square as it is. This is already there. Now 10 to the power 4x into 4 sine cube 3x into cos 3x into 3. So everything is again there. Just 1 by 2 is missing. So dx it is. So your answer will be 10 to the power 4x sine to the power 4 3x upon 2. Limit will be pi by 6 to pi by 3. Now you know how to integrate it. Just put the upper and lower limit. Get your answer. The answer you will get as minus 1 by 18. Got it? All right. Now try this one more. I from 1 to 2 dx upon under root में 2x cube minus 9x square plus 12x plus 4. Yes. Yes, everybody go for it. Yeah. Okay. I'll do it. First of all, what you need to understand, this is an inequality question. So first of all, predict this graph. All right. So your say this is your fx. This fx is 2x cube minus 9x square plus 12x plus 4. What would be f dash x? F dash x will be 6x square minus 18x plus 12. If I take 6 common, it will be x square minus 3x plus 2. That would be 6 times x minus 1, x minus 2. Now, if I analyze between 1 to 2, this is going to be a decreasing function. And this is 1 to 2 is your limits of integration. So between 1 to 2, this function is going to be decreasing. That means f of 1 is what? That would be the maximum value. So f of 1 will be 12 and 4, 16 and 2, 18 minus 9, 9. And f of 2 will be 16 minus 36 minus 20 plus 24, 4 and 4, 8. This is it. So that means your fx lies between 8 to 9. Am I correct? So 1 by fx lies between 1 by 9 to 1 by 8. So 1 by root fx, which is your problem, is lying between 1 by 3 to 1 upon 2 root 2. Am I correct? Now integration 1 to 2, 1 by 3 dx less than integration 1 to 2 dx upon root fx, which is less than integration 1 to 2 dx upon 2 root 2. So this is whole your I. So your I lies between 1 by 3 to 1 upon 2 root 2. Now you square both sides. So your I square will lie from 1 by 9 to 1 by 8. Am I correct? So 1 by 9 to 1 by 8, Calcutta, Bombay is your correct answer. All right. So I think today I have been able to give you something which you have never studied, isn't it? Like you guys have never covered Leibniz theorem. This limit as a sum is also been deleted from board section. So we covered that part also. So now your responsibility is to practice more, do more with this. All right. Now I would like to ask for the small feedback about the class, and then you guys are free to go from my side.